Bismillahirrahmanirrahim. Start with the great name of Allah, who is most merciful and beneficent. Today I am delivering my topic about oxygen diffusion rate meter. Contents of my topic: Number 1, introduction to oxygen diffusion rate meter. Number 2, importance of oxygen diffusion rate measurement. Number 3, principles of oxygen diffusion rate measurement. Number 4, key components of an oxygen diffusion rate meter. Number 5, calibration and standardization procedures. Number 6, factors affecting oxygen diffusion rate. Number 7, applications of oxygen diffusion rate measurement. Number 8, interpreting oxygen diffusion rate data. Number 9, maintenance and troubleshooting conclusion. Number 10, conclusions and future development. Introduction to oxygen diffusion rate meter. Advice to measure the rate of oxygen diffusion through materials. The oxygen diffusion rate ODR meter measures the mobility of oxygen in the soil. Importance of oxygen diffusion rate measurement. Accurate measurement of oxygen diffusion rate is crucial for understanding biological processes, environmental conditions, and product quality control. Enables monitoring of oxygen levels in cell cultures, tissues, and food packaging to ensure optimal growth and preservation. Critical for evaluating the performance of materials, coating, and membranes designed to regulate oxygen transmission. Principles of oxygen diffusion rate measurement. Gas diffusion. Oxygen diffuses through a membrane based on concentration gradients. Measurement techniques. Oxygen sensors detect and quantify the diffusion rate. Standardized methods. Established protocols ensure reliable and repeatable measurements. Three components of an oxygen diffusion rate meter. An oxygen diffusion rate meter comprises several essential components. Number 1, oxygen sensor. Measures the oxygen content of the sample. Number 2, diffusion chamber holds the sample and controls the diffusion environment. Number 3, temperature and humidity controls. Ensures consistent measurement conditions. Number 4, data processing unit. Analyzes the sensor data and calculates the diffusion rate. Calibration and standardization procedures. Prepare standards. Obtain known oxygen diffusion reference materials. Number 2, instrument calibration. Calibrate meter using standardized samples. Number 3, verify accuracy. Test calibration with additional reference materials. Number 4, document procedures. Record all calibration and standardization steps. Factors affecting diffusion rate. There are several factors that affect the oxygen diffusion rate. Number 1, temperature. High temperature increase diffusion rate and lower temperatures can decrease it. Number 2, pressure. Increased pressure boosts the oxygen diffusion through membrane. Membrane porosity. More porous membranes allow faster oxygen diffusion. Surface area. Greater surface area exposure enables higher diffusion rate. Application of oxygen diffusion rate measurement. Many applications of oxygen diffusion rate meter in many sectors: environmental monitoring, access water and soil quality to ensure health ecosystem. It is also applied in agriculture. In agriculture, optimize soil conditions for improved crop growth and yield. It helps in medical, evaluate oxygen levels for patient care and respiratory therapy. Interpreting oxygen diffusion rate data. Understand contents. Consider sample environment, temperature, pressure, and other factors that can impact oxygen diffusion. Identify trends. Look for patterns over time across sample to reveal insight. Compare two standards. Benchmark results against industry accepted norms and regulations. Investigate outliers. Understand causes of unusual high or low oxygen diffusion rate. Maintenance and troubleshooting. Cleaning procedures. Regular cleaning of sensor and components to meet the accurate data. Number 2, calibration checks. Validity accuracy with standard solution. Number 3, troubleshooting tips. Identify and resolve common issues quickly. Number 4, preventive maintenance. Extend the lifespan of the meter. Conclusion and feature developments. Summarize key takeaways and look ahead to advancement in oxygen diffusion rate measurement. Thanks.